Okay, we're going to take all that you've learned so far finally and begin to apply it to atmospheric circulations. Those are what really are going to affect you. They're going to create the hazards you got to deal with as a pilot. So we're finally bringing it back to a point where we begin to see how things apply to you directly as the pilot. We're going to look at first at just a global circulation. You've learned that all the sun's energy does not come in exactly as you would expect it to. So I'm using a Wikipedia page here just to look at the global circulation. So let's just take a look at it. Think about it. All the sunshine coming at the equator. We know that hot air rises. So you got lots of rising motion there. So that's the first beginning of anything. If you had no rotation to the Earth, this would rise here. Coldest air would be at the pole. It would sink there. Would be one big cell of air going like that. But we have rotation to the Earth. So that complicates everything. So about 30 degrees north, we begin to have a descending cell. Cool, dry air coming down at that level. Right across, about 30 degrees north, right across the Atlantic Ocean. Then we go back up and up, warm air kind of moving north typically. But this is where the mid-latitudes, weather can change all over the place in here. So they're the westerlies. Winds are blowing out of the west. So at that point, we have most of the strongest storms are going to be near 60 degrees north, where it is that. But they're going to go back and forth. And then you have the polar cell. Guess what? There's a big high typically over the North Pole. So if you've got to fly over the North Pole, most of the time there's going to be a big high, or the South Pole. So that's your general circulation. And just looking at it, how does it look on the map? Well, guess what? Today, big high pressure, about 30 degrees. And if you go north, 60 degrees. You have one low, a little bit of a low right there, but you have another one here, another one here. And if you kept going around the globe, you'd have another one. Oh, yeah, you go up to the pole, big high pressure sitting up north up there. So the actual circulation of the planet, high pressure, low pressure, all of it kind of is reflected in what the surface weather map looks like. Yeah, there are changes here and there, but you really can pick out an overall circulation to the atmosphere in that weather map. So now let's bring it down to what we're interested in. One of the things you need to know is air masses. What is an air mass? Think of a large area of high pressure. Let's take this area right up here in northwest Canada. Sun's not shining much up there anymore. And guess what? Temperatures are all in the 20s right here. We're talking thousands of miles, all about the same temperature, all about the same relative same dew point, same amount of moisture in the atmosphere. That's an air mass. Think about it. That air has not moved much. High pressure doesn't have much wind motion. So that's the typical continental polar air mass. Dry, cold. And they really do come out of this part of Canada most of the time, moving southeast. And this was one that's now moved down into the area. Once it gets in away from its source region, it begins to modify. It may not be as cold, may pick up a little bit of moisture along the way. And then down here, see this high pressure right here? This is a maritime tropical air mass. Again, high pressure about 30 degrees north, all very similar dew points, all very similar temperatures, basically over the water. So you wind up with that. And right between them is a cold front moving down through here, right in this, where one air mass changes from the other. You'll notice the winds kind of shift. They're more northerly here around the high, more from the east, southeast out ahead of around the big high pressure down here. So they converge along that front. That's why you wind up with the thunderstorms along there as well. And fronts aren't always nice and smooth. They're kind of disjointed. And you can see down here it becomes a stationary front along the Gulf Coast. There's nothing pushing it down. Here's a warm front coming north through Oklahoma right now. You see the south winds ahead of it. More of a southeast winds here. But if we zoomed in right there, you would find Temperatures on one side of the front, mid to upper mid 60s, 70s. On the other side, 40s and 50s. So you can see the temperature change right across that front right now. And same out here in the Rockies and stuff to some point. And also look at the dew point, 64 here, 61 there, 45 degrees, 50-degree dew point there. There's a dramatic change in moisture as too. So this is a maritime tropical air mass moving north. Continental polar getting pushed out of the way or slowly retreating. Remember, cold air is more dense than warm air, so it's going to work that way. So now that we've seen cold fronts, warm fronts, stationary fronts, looking a little bit at the globe as well, here's another picture of right around the whole Earth, and you can see high pressure here, right across 630 degrees north about, over the whole Pacific Ocean, and then all these lows moving across to the north, and then high pressure up to the top. This is just an actual analysis from a model right now. One of the things too with this, say you have a front. Here was a cold front that went through this area down through Florida here and all. As it moved along, what I wanted to show you is, okay, the front's by Tallahassee, but not real far. The top of the front, you'll see the air really warms right in this area here, like 1 kilometer up, or about 4,000 feet up. And then you go up to Atlanta, and it's much further, it's higher up, about 6,000 or 7,000 feet up. So that's the slope of the front. We talked about making vertical velocities, knowing the frontal slope. Well, here's a depiction of that slope. Here is one point near Tallahassee. Here's another point about 3 kilometers up further north. If you were to take that distance and divide it into the height that it went up, you would get a slope that was the slope of the frontal surface, and that could actually be used to calculate what an estimated vertical velocity would be. So now I want to look at cyclone development. We're talking about extratropical cyclones today, development. Here is their jet stream currently around the globe. There's a whole bunch of waves on it. We're not defining these waves too well, but here's one across the Pacific Ocean. Not really a lot of dip to it. It's moving down there, pretty much moving from the west to the east. But here is a dip. And notice there's a little one down here, a little lower jet stream, a little weaker, but still one to the further south. So all this energy coming across the Pacific is getting split. Some of it's going up over Alaska and down. Some of it's coming into California and through. Then they merge back together over the U.S. Where that merge takes place is kind of a favorable place for development of extratropical cyclones. And you can look over the U.S., most of it, and over the Pacific, the Atlantic and all, pretty much west to east again. There's one big over Siberia as well, a big ridge of high pressure being built up there. So looking at that, here is a surface weather map. And what I wanted to do was stop it back here a minute. Notice there's a weak low over western South Dakota right here. Not real strong, 997 millibars. Watch this low as it moves forward. Still 997. Now it's 990, 989. We get up in here, that's a 980 millibar low. Notice the isobars around it have tightened up a lot. Here's your cold front behind it, cold air coming into the west side of the low. That's an extratropical cyclone developing. So if we were to look at the same exact time frame, we started out back here in time. So this was valid on Wednesday of next week at 12Z. So let's look at that Wednesday. There's 12Z. Notice the southwest winds. Oh yeah, you see the sinking motion? The blue lines indicates sinking motion. Think about it. The wind's coming over the Rockies and sinking down here. Now as you move forward in time, notice this low developing up here. Lots and lots of moisture and vertical motion out ahead of it. If you were to look at the other one, back where we just looked, at that same time, see all this precip up here? It's warm air being lifted north. It's following the classic pattern of how these low develops, moving up. And one final piece of the puzzle, if you look aloft, remember how I said these two kind of merge into one big jet stream up here? Look at how strong that jet has gotten. Over 150 knots right in here. And right in here is a very good divergence area, usually to the right rear, like a right entrance region of it where your particles are moving in. Here's your left end. Now if you watch that just going up there, even get bigger and more intense down in here with time. And you can see the low. So the jet's up here, the low's down here. There is that slope in the atmosphere that I want to make sure you understand as well. One of the things too with all of this, I wanted to just show you a quick tropical system. So as we're moving forward here, we have a tropical system coming up off the west coast, way back in time here. It might be better to see it. But remember Roses out there. And it's just not going to show up on my card. But there it is. All right. Here's Rosa. See the intense low at the surface? And this is at 18Z on Monday. Nothing up here. So let's go back to 18Z on Monday. What you see down here is actually high pressure, clockwise circulations. A tropical system does not have depth. Extratropical gets colder and colder with height, stronger and stronger with height. You can see the intense low to the north of this system. Tropical systems are very intense at the surface and gradually change over actually to high pressure aloft. You have a counterclockwise circulation at the bottom and a clockwise circulation as a top. So now we're starting to bring this all together. We're going to really pull in thunderstorms, and then we're going to really move into hazards here in the next couple of weeks. So let me know if you have any questions about this.